Alright class, today we're going to look at properties of logarithms. What you should know is that they relate directly back to our exponent powers, because remember, a log is just an exponent. The exponent's equal to the log base a of the number. So when you have two things being multiplied here, log base a of two things being multiplied, that comes from one exponent added to the other, just like this property over here. Same base, multiplication here with the bases, these exponents are added. So notice how now they get split that way. For the quotient property, same thing. If you have log base a of two things that are being divided, you can take the top one, log base a of u minus log base a of v, and that relates directly to that rule. And finally, a power to a power. A power to power, we ended up multiplying the two things. So, and this is a very important property, because with logs you can bring the power in front and multiply it to the log, because the log is also a power. And that's an important property because that'll allow us to solve things algebraically and get those x's down from that power up there. Alright, so let's evaluate each logarithm. I look at it and I see I have log base 2 of 3 over 7. Since it's division, I know I can take it and split it into log base 2 of 3 minus log base 2 of 7. That's just the property. And then I tell you what is the log base 2 of 3 and what is the log base 2 of 7. It is those two values. So I'm going to put those in now. 1.585 minus 2.807. And you get a value of negative 1.222. Okay. We have the number 21. How can we split that up? Hopefully you guys realize that's 3 times 7. And if it's multiplication, that means we add the logarithms. And so we can do the same thing. And when you add those numbers together, you get that. Alright, and then finally 49 is the same thing as 7 times 7, or we can rewrite it as log base 2 of 7 squared. Remember, if you have a power, this power can come down in front, so this becomes 2 times log base 2 of 7, which is equal to 2 times 2.807, which is equal to 5.614. Okay, so that's an important property to know. Now, today we're also going to expand the expression, which means I want it written out as the individual log pieces, not one big log put together. So let's first start expanding this. First thing I'm going to say is this chunk is on top, that chunk is on bottom, so I'm going to use the subtraction. So the natural log of 5x to the 7th minus the natural log of y. Okay, so now we have to expand the front piece. Be careful here. A lot of people try to bring that 7 down right now. However, the 7 is only attached to the x, so we have to first split up the 5 and the x to the 7th by multiplication. Well, it is being multiplied, so we're going to use the property where it's adding. So this piece right here, or this whole piece, turns into the natural log of 5 plus the natural log of x to the 7th minus natural log of y. Finally, to expand, we want our powers on the in front. Now you can bring this guy down because it's just to that one thing. You can't do it when it was to both of those because it wasn't to both of them. So our final answer is the natural log of 5 plus 7 times the natural log of x minus the natural log of y. And again, I'm just using properties here. Same thing here. Log of 3x to the 5th minus log of y squared. Again, for the y squared we can now bring the 2 down. For here though, we cannot bring the 5 down yet because it's not raised, it's only raised to the 5th, the x. We have to split that up first. So I have log base 10 of 3 plus log of x to the 5th minus log of y squared. And the final step for expansion is bring all the powers down that you can. So I get log base 3, or log base 10 of 3 plus 5 log x minus 2 log y. Now, if you can evaluate the number, I want you to do that as well. But none of those evaluated nicely, so we're not going to do that. Again, we have multiplication between the 3 and the x to the 4th. So the first step is log base 6 of 3 plus log base 6 of x to the 4th. Bring the power down for that one. What power gets us from 6 to 3? It's nothing good, so we leave it like that. Okay. And finally, we have natural log of 5 over 12x. Be careful with this one, because I'm going to split it with the division first. But you have to remember your parentheses. This is where people make mistakes. So, I have the natural log of 5 minus the natural log of 12x. But I have to split this. So I have the natural log of 5 minus parentheses. I have the two pieces now. So you could have either written it like this as a final answer, or you could have told me it is this, natural log of 12 minus natural log of x, because those are both on the bottom. Okay? Alright, now we're going to do two more. This is where we might be able to do some numbers with this. So again, I split it with division first, with subtraction, log base 4 of 64 x to the 9th minus log base 4 of y cubed. Now I split this one here with adding, using the product property. Okay, so this is the one where I was talking about. First of all, again, the powers need to now come down. Okay, but look at this one. This is saying what exponent gets us from 4 to 64. If it's something very simple, I want you to simplify this. So for example, 4 times 4 is 16 times 4 is 64. You could write it like this if it helps you. Log base 4 of 4 cubed plus log, oh, I can bring the power down for these guys. 9 log base 4 of x minus 3 log base 4 of y. What happens to this power? It also goes down, so I get 3. And then what happens to this? You guys should remember this property. What exponent gets you from 4 to 4? Hopefully you guys notice it's just 1. So the final answer is that the log here cancels out, and you're just left with that 3. And that's all we have. Okay? Alright, same thing with natural log. Remember, natural log is base e. So, if I split this with division, natural log of x minus natural log of e to the x. Bring the x down. Natural log of x minus x natural log of e. Guys, remember, when you see natural log of e, you can type this in your calculator. This is the same thing as log base e of e. Again, when the bases are the same, you just get 1. So this turns into the natural log of x minus x, because that goes to a 1. Okay. So now all we're doing is reversing the process here with these last 6. First thing you should do is put the powers back up. So I have log of 9 plus log of 2 cubed. We'll change that later. Minus log of 3. So that's 8. So then I have log of 9 times 8 minus log of 3. I have log of 9 times 8 over 3, which is equal to 9 divided by 3 is 3. 3 times 8 is 24. So I get log of 24 is the combined condensed expression. Alright, this one here. Natural log of 6 plus natural log of 3 to the 4th minus natural log of 3. I'm going to put these together first by multiplication. Natural log of 6 times 3 to the 4th minus natural log of 3. Then I'm going to put those together by division. Natural log of 6 times 3 to the 4th over 3. So that would be 3 to the 3rd, which is 27 times 6. So you get the natural log of 162. So that is the log put together. Again, you can't put them together until the power is there, so this goes up, so it's 9 squared. So you could say this is log of x over 81. Okay. Here, again, the power goes up here with the 3. So I get natural log of 4 times 3 cubed minus natural log of 12. And now we have two of the same, again, logs, so we can use our division property here. Okay, so 4 goes away, 3. So is that just natural log of 9? Alright, let's talk about this one. We have a problem here, but it's not that bad of a problem. We don't have a log with the 2. That was simplified out. Here's what you have to do. You have to turn this into a log. But it's really easy to do. We need it as a log base 5. Well, we have to come up with something that's the equivalent of 1. Hopefully you guys realize that if I write log base 5 of 5, that's the same thing as what it was before. Because that's the equivalent of 1, so we can write that. Now that we have that log, we can put that 2 back up here. So we get log base 5 of 5 squared plus log base 5 of x minus log base 5 of y cubed. Put those together, log base 5 of 25x minus log base 5 of y cubed. Put those together, log base 5 of 25x over y cubed. Okay. Same thing with this one. We need natural log. So that means that the inverse of natural log was e, so we have to change this into a log. And the easiest way to do that is to say it's y times the natural log of e. Now the y becomes a power. And now we can do the subtraction. So we get natural log of e to the y over 4. And that is our final answer. So those are the trickiest ones. Just when you see a number, you have to turn it into a log base that matches the other two so you can work with it. And then we're going to push them together. Okay, good job today.